Hello, everyone. So, today we are going to focus on another new topic, which is numbers of elements less than k, or I could say kth smallest element in given 1D or 2D matrix. These all are lead code hard problems, mostly hard problems, which will be asked in top MNC companies. So, kind of a differentiation, a bifurcation, a subpart of binary search only, but it's a different kind of topic in itself. So once you know this kind of topic, once you know how to solve, there are so many variations in it. We'll be covering, I will almost take 3 or 4 videos on this topic itself with different variations under this itself. So let's just understand the template and what this type of questions mean. We will solve one basic question of this today, and then I'll be giving you some more variations, some more kinds of questions which could come under this category: number of elements less than k, or kth smallest element in given 1D or 2D matrix. So it could be asked that you need to find kth smallest element in a given 1D or 2D matrix. So it's not fixed like the matrix will be sorted only or the 2D matrix will be sorted. No, it could be anything. It could be sorted, it could not be sorted. You are not given fully the 1D matrix or 2D matrix. You might be given the conditions that this is the way you have to make a 2D matrix. This is the way you have to make the 1D matrix. The conditions could be sometimes that you cannot make 1D or 2D matrix, but you have to derive a logic out of it. But basically, you will see this type of question that find kth smallest element in this. Okay, this k could be anything. Some other word will also be used instead of k, but a similar type of question you can compare with this category and then you can solve it. So, first thing, what you need to do for this type of questions, you need to find number of. Okay, first what we will always do, choose L and R, and this is kth smallest element. So of course this is kind of minimum type of question. Okay, this is kind of a minimum type of question. Fine. So minimum of type of question which follows this pattern. Okay, now choose L and R. Okay, we have chose L and R. Find mid. Consider mid as your kth smallest element. So let's say it's been asked that second smallest element you have to find, or third smallest element, or fifth smallest element from all the given matrix or array or whatsoever. So we will find the mid. Consider that this mid should be inside the number of elements given to you. Now that we need to figure out how. These questions will come later. Let's see. So consider mid is your kth smallest element. Now what you have to do? You will make is possible function. What this will return? Yeah, boolean, that I know, true or false. What this function will, how will it decide true or false? So it will return, or what it does is count number of elements. We need to find kth smallest element. So we need to count the number of elements less than mid. Now, mid needs to be kth smallest element. What is our condition? Our condition is mid needs to be kth smallest element. So if, let's say, there is a simple array, consider this simple array. As of now I'm making it sorted itself. Okay, and your mid is, let's say, how will you choose mid which is inside this array only? No, you will make L as 12 and you will make R as 30. So any number between L and R, 30 and 12 could come. So as of now 30 minus 12, any number between these two could become 30 minus 12 is what? 18 by 2, 9. So 12 plus 9 is 21. So let's say your mid is 21. Is there any element with 21? Okay. Now if we run is possible function, I have told you we have to count the number of elements less than mid. So we counted number of elements less than 21. So 1, 2, 3, 4. I got 4 numbers less than 21. I need to find the fourth smallest. Let's say I need to find the fourth smallest element. So I got number of elements less than 21 as how many? 4. Could my 21 be answer, or it could not be? It could be or it could not be, right? Okay. Let's say your mid, let's say your mid is 19. So number of elements less than 19 will be what? Number of elements less than 19 will how many? 12, 13 and 15. Only 3. So 9 less than or equal to also. Let's say, because we have to find kth smallest. So we'll count number of elements less than or equal to mid. 19 less than or equal to 19 is only 3. Less than or equal to 19 is only 3. So for sure this could not be answer. This could not be an answer. 100%. Of course. 100% this could not be an answer. Okay. 21 could be answer, could not be. So if I've got 21, for minimum, what will I do? I'll make R as mid. Okay, so now my range is 12 to 21 only. I'll find something between 12 to 21, and at some point, while calculating, at some point, I'll get what? 20. So for 20 also I'll get 4. Number of elements less than or equal to 20 is also 4. And there also I'll return R as mid. Okay, somewhere I'll be at 2 stages where I'm left with L and R. So we need to find mid needs to be the kth smallest element we have considered. So we need to count the number of elements less than or equal to mid. That should be k. But what if my number of what if my mid is, let's say, 23? Then number of elements less than equal to 23 is 5. So something below 23 could be my answer. Something below 23 could be my answer. So here also I can make my R as mid. But for this type of case, where 19, which is 3, which is not greater than or equal to k, of course I need to go one step ahead only. So I'll start from 20 to R, which is 30. Okay. So we need that count to be greater than or equal to k. So we'll count the number of elements less than or equal to mid. Let's say this is count. We'll return this count to be greater than or equal to k. This condition will be satisfied that the number should be included inside the matrix. Number should be included inside the matrix or array. That condition will be anyways covered because we'll be doing L and R transferring. For sure it will come to those numbers which is present in the array itself. Okay, but the condition true should be, if you count the number of elements less than or equal to mid, that count should always be greater than or equal to k. Logically equal to k is the correct answer, but to decide the range, greater than or equal to k will decide the range from 0 to r or L to r. Otherwise it will L to mid, otherwise it will decide the range of mid plus 1 to r if it is less than k. So this is less than k, 19. So we'll decide the range of mid plus 1 to r, otherwise it will be L to mid. I hope I'm clear. Okay. Now, how to find the number of elements less than equal to mid depends on the matrix or array given to you inside the question. Cool? Okay. So, if I can give you a simple template, then this bull is possible will be there. One mid will be there. One k will be there. Then there could be a single matrix or a 2D matrix or any other extra conditions. You will count number of elements in 1D or 2D array. Okay, that count should be greater than or equal to k. So this you need to return. Number of elements in 1D or 2D array less than or equal to mid, of course. Okay, now you have this main function. You will have one L and R. Okay, L will basic mostly for this type of questions we need to find kth smallest element. So our range will be matrix of 0 and matrix of n minus 1 in most of the cases. Okay, because you need to find the elements present inside the array or 1D or 2D array. So depending on 1D 2D array, your L and R will be the first element and last element after sorting. After sorting. Now this could be the case if it is not sorted, you have to sort it. So L should be minimum, R should be maximum element. You wouldn't have to struggle a lot in defining L and R for this type of questions, as we need to find the kth smallest element which is present in matrix only. Okay, this will be same while R minus L greater than 1. What we will do? Mid as L plus R minus L divided by 2. If is possible. So can my mid be the kth smallest element? So number of elements less than or equal to mid should be greater than or equal to k, and whatever is the vector given to you. If it is possible, we will do R as mid, otherwise L as mid plus 1. Now you are left with again two variables L and R. First we will check for L because it is smallest. Okay, then we will return L, otherwise we will return R. Okay, the basic standard question for it is this type of question. Let me paste it over here. Given an n cross n matrix where each of the rows and columns is sorted in ascending order. So it's given that each row and column is sorted in ascending order, and we have to return the kth smallest element in the matrix. Simple question. Note that it is the kth smallest element in the sorted order, not the kth distinct element. Okay, it's not the kth distinct elements, it's just the kth smallest element in sorted order. You must find a solution with a memory complexity better than big O of n square. Okay, so you need not store this full vector. Okay, you will be given a 2D vector. Let me give you an example. So this is the example. Okay, so what you can do is you can make a single matrix out of it. 1 5 9 10 11 13, sorry, 10 11 12 13 13 and 15. So this is your single 1D matrix you made out of this. But this has time memory complexity of what? Space complexity of what? N square, because you used all those numbers and stored in a 1D array. And now you will find kth distinct kth smallest element. So eighth smallest element will be nothing but the seventh index. Okay, there's matrix of 7. This is very brute approach, but they have told us not to use memory complexity of O of n square, to use something better than that. So this we cannot do. This will be a brute force. Okay, this will be a brute force. We have to do something better than this. What? So we know that how we need to find the kth smallest element in the sorted matrix. So our first condition, L will be 1 for sure, R will be 15. Something between 1 and 15 will be our answer. Okay. Now, now they have said if there are two 13s, okay, so eighth smallest element will be first, second, third, fourth, fifth, sixth, seventh, and eighth. Seventh is also 13, eighth is also 13, but still we have to return 13 and not 50 because they haven't asked kth distinct element. Okay, they have asked just kth element in sorted order. Okay, so now our main condition is to find count or find number of elements less than equal to mid. That is our main condition. Okay, how we will find that? Number of elements less than equal to mid. So, do you remember any other binary search STL? We have already learned to find the number of elements less than or equal to mid. We already know what? Upper bound, to count the number of elements less than or equal to mid, because upper bound will always point to a number greater than value, greater than mid. If I'm finding for mid, and if I do upper bound on particular row, I'll get number of elements less than or equal to mid. So I'll move to that particular index which is greater than mid. So let's say you have this array. Okay, let us draw over here and understand. So we have this array. Okay. 1, 5, 9, 10, 11, 13, 12, 13, 15. So for each row, we will apply upper bound. And let's say I want to find the number of elements less than mid, less than or equal to mid. Consider my mid as 12. Okay. Consider my mid as 12. So if I found the upper bound for this particular row, I can do. I know the upper bound formula for 1D arrays, not for the 2D arrays. Okay. So for first row, I did the upper bound for 12. What will I get? Something greater than 12. My upper bound will give me a pointer or index of something greater than 12. So it's not present. So it will give me ends index, right? So that means all this 3 is my number of elements less than or equal to mid only. Okay. So it will give me which index? End index. End index is 0, 1, 2, 3. Something out of this. So it will give me 3. So that means all these 3 elements are less than or equal to mid. That's why I got 3. Okay. Here what will I get? 12 something greater than 12. So I'll get this pointer, this index. This index is what? 2. And that means there are 2 elements which are less than or equal to 12, 10 and 11. And here something greater than or equal to greater than 12, upper bound. Okay. I'll point to 13. Then my index will be 1. So that means there are only one element which is less than or equal to 12. So this 3 plus 2 plus 1, 5 and 1, 6. We need to see is 6 less than or is 6 greater than or equal to 8? 6 is not greater than or equal to 8. So 12 couldn't be my answer. I need to start from 13 now until R, whatever is my R. Okay. I hope you got my point. What if the mid is 13? I'll get 3 over here. I'll get 3 over here also, and I'll get 2 over here. So 3 plus 3 plus 2 will be 8. So count is greater than or equal to 8. This will return true. Okay. So now my R is 13 fixed and my L is 12 or L is also 30. This couldn't be the case. Both same. There will be one difference. So L will be 12 and R will be 13. Then we'll first check for L and then we will check for R. I hope you got my point. Okay. Without wasting time, let's just solve the question. Okay. So we will have int n is equal to matrix dot size. L will be matrix of 0, 0. R will be matrix of n minus 1, n minus 1. Okay. While R minus L greater than 1, mid will be L plus R minus L divided by 2. This mid is not the index. Again, to make you sure, this is the element. Okay, kth smallest element. If is possible for mid k this matrix and let's say I'm passing n also, then what will I do? R as mid. Okay, there could be something less than this also possible. We have to check. Otherwise, if it is anyways less than k, then of course this couldn't be my answer. I need to go ahead of this. So L is mid plus 1. I'll check for L, k matrix and n. Else I will return R. Now, this would have mid k matrix and n. So we will have number of elements less than or equal to mid we need to find. So for each row, this is I'm traversing for each row. For each row, I'll do count plus equal to upper bound for matrix of I. This will be my row. Matrix of I will be my row, a full row. Matrix of I dot begin to matrix of I dot end and for which value mid minus matrix of I dot begin. 1D arrays. Okay. For single rows I am doing. And this I'm anyways adding in my count. So I have to return this count greater than equal to k. This count should be greater than or equal to k. Let's see. If it is greater than or equal to k, it will return true. That means we have to go in the range of L to mid, otherwise mid plus 1 to R. So we haven't stored the values in any single array. Okay. This is how we can solve this type of questions. I hope you have got. I can give you a brief description for this question and then you can solve it. So the question says that you are given an array nums containing n plus 1 integers, where integers is in the range of 1 to n inclusive. So there are total n plus 1 integers. All integers will be from 1 to n only. There is only one repeated number in nums and we have to return this repeated number. You have to solve the problem without modifying. So we cannot sort the array. And it's not said that the array is sorted, and we have to use only constant extra space. So let's say this is the question. Okay, so size 6, 1 to 5, only one number is repeated, which is 2 in this case. So n is 5, n is 5, and the array size will be n plus 1, which is 6. Okay, how will we do this? So what we will do in this type of question, how we will convert it to what we have learned above. There we need to find the number of elements, kth smallest element, right. So here what we will consider, here we will consider, okay, every time we will consider mid as what, as repeated number. Always take mid as what is asked in the question. Okay, so we will consider that, okay, mid is the repeated number. Okay, we need to find number of elements less than or equal to mid. Okay, let's say mid is 3. I have to find number of elements less than or equal to 3. I cannot sort this. So only way I can find is I can traverse this array and I'll find 1 is less than equal to 3, count plus plus. 3 is less than equal to 3, count plus plus. 2 is less than equal to 3, count plus plus. And this 2. So how many elements I have found? 4 elements I have found which is less than or equal to 3. When can this be possible? When can this be possible? Number of elements less than or equal to 3 is greater than 3. 4. 4 is less than equal to 3. Okay, so number of elements, we have found the number of elements less than or equal to mid, which is 4. Okay, now we have been told that the numbers are from 1 to n only. So for sure there is some number between 1 to 3 only which is repeated. That's why the count has become 4. Otherwise the count wouldn't have been. So in this case our R will be mid. Otherwise our L will be mid plus 1. But is this condition that 4 less than or equal to 3 means count greater than or equal to k, we need to return as true. Now consider one of the case. So in above what we are doing, we are finding count greater than or equal to k. Okay, because we have to find kth smallest element. What if there will be 2, mid as 2 only. So number of elements less than or equal to 2 will be 3. 3 is always greater than 2. So we'll return that. What if it is 1? Mid is 1. So number of elements less than or equal to 1 is 1. And that is true in the means that couldn't be the sign of repeated number. If it is equal to k, okay, if it is equal to k, for sure it couldn't be less than k. You find any mid, for any mid, number of elements less than or equal to mid can never be greater than mid. For this question I'm saying. So if you find number of elements less than or equal to 5, it should not be greater than 5. Of course, it can never be greater than 5. It could be either equal to 5 or greater than 5. Okay, so when it is greater than 5, we will return true. Otherwise, we will return false. So our condition here will be count greater than k and not count greater than equal to k. I hope you have got it. Okay, try to solve this question. I'll put in the description, and in the next video, I'll be covering a slightly harder type of questions which you will find the lead code hard tag. So stay tuned for the next video. Do like, share, and subscribe if you have learned a lot out of this video. Stay tuned, stay safe. Bye bye.